Hello class, Mr. Schweizer here to explain to you how to do the second part of the lab where we're determining the acceleration due to gravity. I know I'm also over there behind the desk, but it's really important for you to actually see it from this perspective. So I want everyone to see it from the same perspective. So first off, you're going to need a string pre-cut. I've got them up on the table, and a washer. Also, you're going to need a stand and an O-ring. One of the groups is going to actually hang it from this thing, and that should be really cool. But this is where we're going to be at for now. So what I did here was I tied my string to the washer first. It doesn't really matter the order, but I did it to the washer first, as you can see here, right? And then I tied it to the O-ring. It's important to double knot these. Maybe even you want to triple knot this, just because we don't want this to budge at all. And notice that my string is actually hanging straight down. So my knot is on the bottom part of this O-ring. It's not twisted up to here, right? It's all the way down here because we want to keep this distance between this bottom of the O-ring to the washer the same. So we need to do two measurements here. We are going to measure consistently from the bottom of the O-ring in centimeters to first off the top of the washer, which is, and the accuracy really matters. And then we're going to measure it from the bottom of the O-ring again to the bottom of the washer. So pretty much what we're trying to figure out is how far this string length is to the middle of the washer. So we get the distance to the top of the washer, just to the bottom of the washer, and we find the average between those two. It's in the directions. Check them out. So next, what we're going to do is we are going to let this swing back and forth. Check out the possible issues. That's an issue. We don't want it to hit the table, so I'm going to actually put this whole setup on the edge of the table. Still, you can have some issues. What I'm going to do here is carefully lift up my washer, and honestly, it does not matter if you lift it up to here or if you just lift it up to here. It's going to take the same amount of time to swing back and forth. All right? There's an issue right there possibly. So just be really careful that this thing doesn't fall off. If it does fall off, make sure that your feet and your face are out of the way. So what I'm going to do is I'm going to let this swing back and forth 20 times. So one oscillation is technically forward and back. So you'll count that as one. So I go 1, 2, 3, 4, 5, and so on. But what I want to do is I want to have a timer, just like we did in the first part. We want to have a timer here set up so that we can see the initial time from when I drop it to the final time when it makes its 20th oscillation. And the accuracy here really does matter. You want your numbers to be as perfect as possible. So the distance between the bottom of the O-ring and the middle of the washer is extremely important, and getting the perfect or as close to perfect times of 20 oscillations is really important as well. So once you get that data, you fill in the data table, you got your distance is going to remain the same. Hopefully your times also remain the same, but if there's little variations, that's okay. But remember, it does not matter if you drop the washer from high up or down low. It will take the same amount of time to swing back and forth, which is why this is such an accurate way to determine acceleration. Okay? So now I'm going to show you, this one over there, how to do the math for this once you figure out all your numbers for data collection. Okay? Cool.